Hey everyone, welcome to This Explainer. Today, we've got a very clear, focused mission. We're unlocking the black box of ChatGPT. I mean, if you've ever typed a prompt into a chatbot and thought, what is actually happening behind the scenes right now, you are absolutely in the right place. We're going to break down some seriously complex concepts, stuff like transformers and autoregressive modeling, and we're going to do it without losing a single ounce of technical accuracy.
Because, let's be honest, when we use tools like ChatGPT, it totally feels like sci-fi magic, right? The machine types back in this conversational, incredibly human way. But the reality? It's not magic at all. It's literally just math. Okay, let's dive into this and start unpacking exactly how those mathematical operations actually come together to create this illusion of thought.
There's this great idea from Mortimer Adler that basically says if you can't express what you think, you don't actually know it. And to guide us on this journey, we're pairing that philosophy with a principle popularized by the Nobel Prize-winning physicist Richard Feynman. It's called the Feynman technique. The core idea is just so powerful. If you can't explain a concept simply, you simply don't understand it. So we're going to strip away all the intimidating jargon and get right to the core of what AI actually is. To keep things easy to digest, we're chunking this explainer into 4 parts. 1. The magic of AI. 2. Predicting the next word. 3. The transformer engine. And 4. Keeping AI safe.
All right, part 1. The magic of AI, the Feynman approach.
So, the Feynman technique is just 4 simple steps. You choose a concept, you teach it to someone else, you identify and fill your knowledge gaps, and then, crucially, you simplify it with analogies. For this explainer, we are leaning heavily on step 4. We'll use analogies to bridge that gap between everyday logic and the heavy computer science running under ChatGPT's hood.
Which brings us right to section 2, predicting the next word.
Before we can even look at the engine powering a chatbot, we absolutely have to define its main job. So the crucial point is this: AI language models aren't thinking, not in the human sense. What they're doing is called autoregressive language modeling, which is just a fancy way of saying their one and only goal is to predict the very next word in a sequence based on the previous words. In a way, ChatGPT is essentially the universe's most mathematically complex version of your smartphone's autocomplete. It's just calculating the probability of the next logical step over and over again.
But here's the catch. AI doesn't read words like you and I do. It reads numbers. To process our text, it breaks words down into what are called tokens. Think of tokens like individual puzzle pieces. A token could be a whole word, a piece of a word, or even a tiny patch of an image, all represented as a mathematical vector. The AI feeds these puzzle pieces into its engine, which is how it can seamlessly process massive amounts of text, code, or images. So now that we know the goal is predicting the next puzzle piece, how does it actually do it?
Let's get into section 3, the transformer engine. This is the revolutionary architecture that makes modern AI possible. Now, if you look at the original research paper that introduced transformers, the schematics look, well, highly intimidating. Honestly, it's just a wall of complex boxes and Greek letters. But don't let that overwhelm you. We're applying the Feynman technique right now to break this down into a completely logical, simple flow. Instead of a complex maze, just picture the transformer as a linear assembly line with 4 steps. First, it takes your input and tokenizes it. Second, it passes those tokens through a self-attention mechanism. Third, it refines them through a multi-layer perceptron, or MLP, which basically acts as a filter. And finally, it spits out a prediction. The data just moves straight down the line. Let's zoom in on that second step, because that is where the real magic happens. Self-attention is the mechanism that gives AI its understanding of context. In older AI models, words that were spaced far apart in a sentence kind of lost their connection to each other. But in a transformer, self-attention treats all words equally, no matter how far away they are. It literally calculates how much each word cares about every other word in your prompt, building this incredibly rich web of relevance. Now, what's really interesting here is how the math acts exactly like a digital filing system. To figure out which words relate to each other, the attention mechanism uses 2 parameters called queries and keys. It multiplies them together using a dot product. It's like, imagine you walk into a library with a specific question. That's your query. You match it with the correct book's title. That's the key. That mathematical match is exactly what tells the AI which words belong together conceptually. But once all these massive calculations fire off, the data needs to be stabilized. Otherwise, the whole model would just crash. That's where something called layer norm comes in. It stabilizes each individual token separately across its features. Think of it like a really attentive audio engineer, constantly adjusting the volume knobs for different instruments so the song doesn't just blow out the speakers. It's a stabilizer that lets these massive neural networks actually process data reliably. Of course, even with an incredibly powerful engine predicting words, we have to remember, a raw engine is incredibly dangerous without brakes and seatbelts.
Which leads us perfectly into Section 4, keeping AI safe.
When you deploy an AI into the real world, you absolutely cannot just let the raw math run wild. Microsoft and other developers use what's called a defense-in-depth approach, meaning multiple layers of safety. If a user tries to input a malicious or unsafe prompt, platform-level safety measures, like content classifiers, instantly kick in. They act as a protective shield, blocking potentially harmful content before the raw engine even has a chance to return it.
To formalize all this, leading tech companies heavily rely on the NIST AI Risk Management Framework. It breaks safety down into 4 ongoing functions: govern, map, measure, and manage. Seeing this structured process really proves that safety isn't just an afterthought. It is actively, fundamentally engineered into the product from day one. Now, unlike the intricate math we looked at earlier, governance is entirely about human oversight. The govern function establishes the policies and the proactive risk management architecture. It basically ensures that principles for responsible AI are baked into the entire development lifecycle. Humans setting the standards for the machines. The next 3 steps, that's where the hands-on testing happens. First, they map the risks through red teaming. This literally means paying experts to maliciously attack the AI to find vulnerabilities. Next, they measure those risks using automated pipelines that simulate adversarial conversations. And finally, they manage the issues, for example, by forcing the AI to ground its outputs in verified documents, instantly correcting ungrounded sentences. And here's a brilliant real-world application of these safety layers. To manage AI risks during the 2024 global elections, Microsoft automatically embedded cryptographically sealed metadata, called content credentials, right into AI-generated images. By securely tracking the digital origin of the content, they created a verifiable safety wrapper to help stop deceptive deepfakes from spreading. And this brilliantly illustrates the continuous nature of AI safety, using a break-fix iterative framework. It's a loop. You probe the model, you find the vulnerability, you fix the data, you post-train, and you measure it all again. It is a relentless, cyclical process of refinement that happens long before a model ever reaches the public. So, let's tie this all back to your daily experience. The next time you type a simple prompt into ChatGPT, think about what's actually happening under the hood. You're kicking off an instantaneous operation of tokenization, self-attention matrices, query key dot products, and multi-layered safety classifiers. Behind that super clean, simple chat interface is a highly stabilized, rigorously governed prediction engine doing billions of calculations a second just to find the next logical puzzle piece. We've covered a massive amount of ground today, from probability math all the way to AI safety frameworks. So to lock in this knowledge, I've got a challenge for you. Using the Feynman technique, how would you explain what you just learned to a friend using an analogy? Try it out, test your own understanding. Thanks so much for joining me on this explainer, and keep exploring the fascinating mechanics of the technology shaping our future. Catch you next time.